Dimap builds special sensors in aircraft and fly with them over targets like forests, mines, to find minerals, to identify environmental pollution. In the 2019, we have collaborated with the University of Hong Kong on remote sensing survey research and produced an introductory video to introduce the process and practical applications of remote sensing measurement.
Remote sensing is an essential technology for studying minerals and rocks in remote parts of planet Earth or on other planets that we can't physically access. By using visible images, we can map out geologic structures or geomorphology, that means the shape of the land. Minerals form through geologic processes, and so understanding which minerals are present tells us which kind of processes have affected different planets.
Dimap is a company which built special sensors in aircrafts and fly with them over targets like forests, mines, to find minerals, to identify environmental pollutions. While we can analyze samples down to a resolution of 0.3 millimeter, the university laboratory of Dr. Michalski can do it down to the microscopic level and add, therefore, additional dimensions to our analysis.
At the Planetary Spectroscopy and Mineralogy Laboratory here at HKU, we have some of the most advanced instrumentation available. When we go on site in the field, we collect rock samples and bring them back to the laboratory. We can use our infrared microscope to collect reflectance data of light from very small parts of the sample. These instruments provide infrared images and spectral fingerprints of the geological materials in the lab.
In the high Andes in Peru, we have a client which searches for copper deposits. The airborne analysis gives a fast way to identify hotspots, targets for further exploration, and Dr. Michalski helped us with academic advice and special analysis in his laboratory.
Yeah, I'm quite interested in this particular type of rock here, which I think we sampled in that spot from that mineral deposit.
That's correct.
So we can put this in the spectrometer here and connect what we see on the ground to what we see from the survey.
Let's do that.
In the Andes Mountains, we look for hydrothermal minerals. That means minerals formed by hot water. Holger, I'm pretty happy with this spectrum, which shows clear evidence for the minerals we've been looking for, which is important for the mining company. And it links up well with what you've accomplished using your aerial survey.
Yes. It is important that the university has the capabilities to go into the microscopic level, while we can then adopt their results and go into the airborne levels.
By using these laboratory data, we can connect the detailed mineralogy of specific samples to what we see in the bigger scene using remote sensing.
Microplastics are everywhere, in all water that we look at and in all beach in Hong Kong they are there. I'm looking at understand the abundance of microplastic in the Hong Kong waters and the marine environment in general. These are the pellets from the spill that happened a few years ago. We still find them in the water. Can we try to identify where are the leftover?
Yeah, material of this size, a few millimeters across, we can make a miniature remote sensing image of that, where for each pixel, we get a fingerprint of the type of plastic or type of material in there.
Together with Dr. Michalski, we are working on a knowledge exchange to build together a research that can help us identify the microplastic directly in the field.
We can use remote sensing to monitor gases in the atmosphere, pollution in the atmosphere, or pollutants on the surface. What makes our work unique is that we can take all of these remote sensing studies on Earth and we apply them to Mars or other planets. When NASA sends rovers to Mars, they use instrumentation to look at the detailed mineralogy of samples at very high resolution. We're doing that in our laboratory to prepare for China's mission to Mars and for future missions to the Moon and other planets. Remote sensing is an incredibly powerful tool that allows us to understand big, complex systems on this planet. Looking toward the future, remote sensing will only become a bigger part of how we see our own planet and how we map distant worlds.